solve systems of equation using elimination. We have two equations and two variables, x and y. We want to be able to eliminate one of the variables. To do this, we need one of the variables, either x or y, to have the same coefficient in both equations, but the signs are opposite of each other. Let's take a look at our first problem. We have 2x in both of the equations. We need one of these equations to have a negative 2x. So I'm going to multiply by negative 1 to the first equation. The negative 1 will distribute to each of the terms and give us negative 2x minus 5y is equal to negative 8. And this is the same equation that I've already written over here. Now we're going to add the two equations together. These two terms cancel out. And we get negative 2y is equal to negative 2. With one variable, we can solve for that easily. Divide by negative 2 on both sides. And we get y is equal to 1. Now we can substitute y into one of these equations and solve for x. I'm going to use the second equation. So we have 2x plus 3 times, I'm going to substitute the y, which is equal to 1, is equal to 6. So you get 2x plus 3 is equal to 6. Subtract 3 on both sides. We get 2x is equal to 3. Divide both sides by 2, and we get x is equal to 3/2. And that's our solution to this problem. And you can write it like this, 3/2 as an ordered pair, x and y. What happens when the equations do not have a term with the same coefficients? Let's take a look at our next problem. We have 3x and 5x, and then we got 2y and y. If we multiply this equation with negative 2, we'll get negative 2y. So let's do that. We've distributed 2 to each of the terms. We get negative 10x minus 2y is equal to negative 20. And this is the same equation. Now let's add the two equations together. The 2y and negative 2y are going to cancel. And we're left with one variable. Negative 7x is equal to negative 14. Divide by negative 7 on both sides, we get x is equal to 2. Now that we have x, we're going to substitute this back into one of these equations. Let's use the first one. We get 3 times 2. We're substituting this 2 plus 2y is equal to 6. We get 6 plus 2y is equal to 6. We're going to subtract 6 on both sides, so we get 2y is equal to 0, and we get y is equal to 0. So when we divide by 2, 0 divided by anything is going to give us 0. And you can write as an ordered pair 2, 0. In the other problem, we change one of the equations, but that doesn't always work. Sometimes we have to manipulate both equations. Let's take a look at our next problem. We have 4x and 3x. 3x doesn't go into 4x evenly, so we cannot just manipulate one of the equations. 3y and 5y, same thing. What we want to do is select which variable to eliminate. Normally, I would say select the one that is easier, but I think it's the difficulty is the same on both of the variables. So let's just pick x. What we need to do is find the lowest common multiple of the x coefficient. 4 and 3, the lowest common multiple is 12. We need to change this to 12x and this to negative 12x. So let's do this. We're going to multiply by 3 on this one, and then we're going to multiply by negative 4 on this. 3 times 4x is going to be 12x. Negative 4 times 3x is going to be negative 12x. Let's multiply this. I distributed 3 to all the terms of the equation. 3 times 4x is 12x, 3 times 3y is 9y, and 3 times 7 is 21. And multiply by -4 to each of the terms, and this is what we get. The 12x and -12x are going to cancel, and we're going to get -11y is equal to -11. So we get y is equal to 1. Now we can substitute y back into one of the original equations. Let's use this one. So we have 3x plus 5 is equal to 8. I'm going to subtract 5 on both sides. Get 3x is equal to 3. Now we get x is equal to 1. And that's our solution. You can write this as an order pair 1, 1. And that's it for this video. I hope you enjoyed it or learned something new. If you did, add a like and subscribe. Thanks for watching. See you next time.